All right, ladies and gentlemen, you're going to be doing the balanced and unbalanced forces laboratory activity. Looks like that right there. A couple of things to note here. The scale that you're using when we're drawing these things out, 1 centimeter is equal to 1 Newton. Newton is a measurement of force. I'll be showing you how to do that in this example and how to carry this thing out. There's also a picture right here that's showing you what it looks like. All right, first thing we're going to be doing is we are going to be using the spring scale to measure the weight of the block in newtons, okay? Because the block, of course, is pulled on by gravity, right? And so gravity is going down, and that is pulling the block downward. We're going to figure out how much weight that is. Now, you got two types of Newton meters in this lab. You've got this one right here, which is the Ohaus spring scale. Now notice that right here it says 0 newtons, but notice that that little metal thing right there, that is not on 0 newtons. So you need to fix that first. This is called calibration. So we're going to go up here. There's a little metal tab, and it moves the scale up and down, right? So I can just push. Oh, went a little bit too far. So now I want to push it back down, and now, if you see, it's at 0, okay? Now, the other type of spring scale, one of the newer ones, looks like this. You notice you got newtons on this side and grams on the other. We're always going to be using newtons. Now, if you look right there, and you can see that it is definitely not at 0, okay? There's a little screw on the top. It's attached to that spring, and you can use the screw to move the little plunger up and down. Okay, so now, oh, I'm going the wrong direction. So now I'm going to go the other direction. And I'm going to screw the thing up. Move it up, move it up. Almost there, almost there. Now I'm at 0, okay? So you can pull down, and it will show you how many newtons something is. All right, so going to put the block on my Newton meter, and I'm going to hold it so that the block is free, right? It's not resting on anything. I'm going to bring it back here, and you can see that the Newton meter is reading between 3 and 4, okay? So the Newton meter is reading between 3 and 4, all right? Now, I'm going to turn it around and have a good close look at it. The Newton meter is reading 3.4 newtons, because every one of those little lines is a 0.2. So this Newton meter is reading 3.4 newtons. So in your lab, you would write that down right here. All right, so 3.4 newtons. So I'm actually going to record that here. Weight is equal to 3.4. All right, now, before I do anything else, okay, I can begin to draw this in, because I know that my weight, and I'll move this back here, I know that my weight is pushing down on the block, okay? So I'm going to draw this like you would draw it. 1 Newton is equal to 1 centimeter. 3.4 newtons, I'm going to draw 3.4 centimeter arrow straight down. So 3.4 newtons, okay? So that is what my downward force from gravity looks like. Now, if that was the only thing acting on the block, then the block would be moving down, but it's not, because clearly it's laying on the table. So the 3.4 down must be counteracted by a 3.4 up, so that the block doesn't move up or down, so that the forces are balanced, okay? So I'm going to draw another line that is 3.4 centimeters up. And that is what's acting on my block when it's just sitting here on the table. Yeah? Now, depending on the scenario that you're using, it's going to give you different directions. So what I'm going to do now is I'm going to hook my Newton meters in there, and I'm going to pull 5 newtons in each direction, okay? Now I'm only going to be able to show one of these at a time, all right? But here we are at 5 newtons in that direction, okay? 5 newtons is right there. Now you can't see it, but my other Newton meter is also at 5 newtons, all right? So the block clearly not moving. So when I go to draw that, I have a 5 Newton force going to the right. That's 5 centimeters. And I label it 5.0 newtons. And then I've got a 5 Newton force going to the left. That's 5.0 newtons, 5 centimeters. And overall, my block looks like this. Now, left and right, 5 newtons in both directions. So the block does not move. Up and down, 3.4 newtons in both directions. So the block does not move. So up and down, 3.4 is equal to 3.4. So that is balanced. 5 newtons to the left is equal to 5 newtons to the right. That is also balanced. So 3.4 newtons down, 3.4 newtons up, 5 newtons to the left, 5 newtons to the right, balanced. So that's balanced. There's not going to be any motion at all. And that is the way that you do this particular activity. Please let me know when you finish the first page so I can check and make sure that everything is going okay.